Okay, so this is the second time I'm recording this video because the first one was without a mic. So let me re-record this real quick. Basically, these are the formulas you need to know. There's a lot of electric field. It's a lot, like electric field, electric flux. Okay. First one, electric field due to a positive charge. Very simple, kq over r squared. You're familiar with this. Or instead of k, you have 4 pi epsilon naught at the bottom, which is the same thing. But this is nicer. I like this. All right, now charge conductor with radius r. Kaman. Same thing, but you need to know that if the distance is less than, like, let's say you have a charge conductor with radius a, if the distance r is less than a, so you're inside, then your electric field will be 0. You'll only get an electric field after a, so when you're on the outside. So how will the graph look? Because they're gonna ask you this in the written part most probably. This is how the graph will look. So from 0 to a, since you're below a, every time you're below a, your electricity will be 0. Your electric field will be 0. Then after it, it's just going to be an inverse square. Anyway, electric in a uniformly charged field, this doesn't really come, but this, you need to know these, alright? In a one-dimensional sphere, the charge q is equal to lambda L. Lambda is given. The charge q here is sigma A, which is also given usually, and the charge in a three-dimensional is rho v. Type. Let's say they gave you sigma and you need lambda. How do you do it? You want to convert from 2D to 1D. So you have to go sigma times 2 pi r, alright, because L is 2 pi r. So you want to go from sigma to to lambda, you just multiply by 2 pi r, okay, because this you're going to use this in the quiz. Now for a Gaussian surface, anytime you have a Gaussian surface, anytime you want to find electric field, anything, if it's written, you write it down like this. You write this. If it's computer part, you write q enclosed over epsilon naught equals E. You write this down on your scratch paper and you solve. Now, if they give you a wire and they say from a distance r find the electric field, you have to use this formula, lambda over 2 pi epsilon naught r naught. Alright? Then, if you have plates, for one plate, the electric field is just this. If it's two plates, the two cancels out and you have sigma over epsilon naught. And the electric flux in general is just equal to this. Okay, if they say calculate electric flux, they give you E and A, you just do this. Alright? So let's solve. So here they're saying two oppositely charged plates. What's the formula? Sigma over epsilon naught. So what's the numerator? It's the surface charge density, sigma. And what's the denominator? It's epsilon naught, which stands for the electric permittivity in free space and vacuum. Okay? And by the way, since you're going to use this, you need to have this memorized. It's a constant, and it's 8.85 times 10 to the minus 12. Alright. Question 2. A conducting spherical shell of radius 13 carries a net charge of this. What's the magnitude of the electric field just outside the shell? So easy. I told you, when you're just outside the shell, when you're outside greater than a, you use kq over r squared. Okay? So it's going to be kq over r squared. So it's going to be 9 times 10, 9 times 5.07 times 10 minus 6 all over r squared. So 0.13 squared, and you get this answer. Alright? Question 3. Okay, the electric flux through a spherical Gaussian surface. I told you for any Gaussian surface, electric flux, so easy. It's just q enclosed over epsilon naught. Okay? Or EA. But here they gave you the q, they gave you epsilon naught, so it's so easy. Electric flux, denoted by this, okay, is equal to q enclosed over epsilon naught. So it's 8.85 times 10 to the minus 12 over 8.85 times 10 to the minus 12. ليه minus 12 فوق؟ لأنه it's p. Pico يعني negative 12. So you get 1. Question 4. A cylindrical metal can has a height of 27 and radius of 11. So this can give me like an area. Alright, an electric field is directed outward along the entire surface of the can with a uniform magnitude of this. So they gave me E. How much charge does the can contain? So they want Q. Anytime you will have anything like this and charge وهيك you write down Q enclosed over epsilon naught equals EA, since it's computer part. What do they want? They want Q. So easy. Q enclosed is just going to be EA epsilon naught. Now it's very important that the electric field is directed outward along the entire surface. So which area am I going to find? The entire surface area. And since it's a cylinder, so what's the surface area, the entire surface area of a cylinder? It's 2 pi r squared plus 2 pi r h. Okay, so let's find it. E is what? 4 times 10 to the 5. A is 2 pi r squared plus, sorry, let me actually put the numbers. 2 pi r is 0.11 squared, so 2 pi r squared, plus 2 pi R again 0.11, H is what, 0.27, okay, times epsilon node 8.85 times 10 to the minus 12. So you're gonna get this. Alright, very easy. Question 5. Alright, now this is the same question. Alright, they gave you the axis of his cylindrical surface, 0.8 long, 0.2 in diameter. But what's the problem now? They're saying that the electric field is not along the entire surface, it's along the x-axis. So when you find the area, you don't find the full area, okay? You just find the area that's passing through this. And what's that? That's just these two. Alright, so those areas. We'll get there in a sec. So they gave me now that it's E1 and E2. So is it uniform? No, there's two different electric fields, E1 and E2. Okay, so that's when you have something like this, you have to do it separately. I'll do it in a sec. So they gave me the magnitudes of them, and what are they asking for? The net charge. So same thing, okay, same thing as the last question, because we have the area, we have the electric field, we want Q. Alright, so what do you write? Q enclosed over epsilon node equals EA. So Q enclosed will be EA epsilon node. So what's the problem? The problem is you have different E's. Alright? You have different E's. Oh, the area is only these. How do you do it? When you're in a case like this, when you have different E's, you need to find E1A1 and E2A2. Then you add them together. So let's do it. E1A1. What's the first electric field? The problem is, since it's two different electric fields, you need to figure out which one's positive, which one's negative. Okay, someone's gonna say they're moving in the same direction, so they're gonna be positive. La, that's not how it works, okay? One has to be positive, one has to be negative. How do you know which one's which? So easy. If the electric field's going towards a place, doesn't the electric field go towards the negative and leave the positive? بالظبط. So over here it's going towards here, so that means here is gonna be negative. Or here it's leaving here, so that means here it's positive. Alright, so here it's gonna be negative 6. So we're gonna say E1 is negative 6. E2 is positive 4 times 10 to the 3. Alright, so easy. Alright, so E1A1 simply will be negative 6 times 10 to the power of 3 times the area. First area is what? The area of this, the area through A1, which is pi r squared, right? What's the radius? The radius is 0.1, and they gave me diameter, so I divide by 2. Alright, now E2A2 will be 4 times 10 to the 3 times pi times the radius squared, again 0.1 squared. Alright, so let's add these together. You get negative 20 pi. Alright, so Q enclosed will be negative 20 pi times 8.85 times 10 to the negative 12. Okay, why did I multiply by 8.5? Because it's epsilon node. We found EA, we found it's negative 20 pi. Okay, 8.85 times 10 to the power of negative 12. Why am I multiplying by it? Because it's epsilon node. Okay, so alright, so you get this, make it nano, so you times 10 to the power of 9, you get this. Alright, very easy. Okay, Q6. Okay, this is very easy. Follow this rule. It's a grid question, so you need to note. Okay, follow this rule. The shaded conductor has a total charge of +9, so the total thing is +9. The charge within the cavity is -7, so here it's -7. Always remember this rule. Okay, if it's -7 here, on the outside it needs to make it 0. So on the inner surface it's gonna be +7. طيب on the outer surface مش كلها it's +9. طيب إذا هون +7 to become +9 يعني how much do you have to add? +2. Okay, this exact method of solving you need to follow it. Next question is the same exact thing كمان. Okay, look, a positive charge 8 is placed inside the cavity. طب إذا هيدي inside the cavity, so on the inner surface it needs to cancel it out. I told you always have to have net 0 inside, so cancel it out, so inner surface should be -8. طيب إذا كلها 8. Okay, إذا كلها 8 يعني how much will the outer one have to be? 8. Okay, so easy والله, so easy. ماشي. Question 8. Two large conducting plates carry equal and opposite charge. Two large conducting plates يعني انت which rule will you use? sigma over epsilon node. Okay, that's gonna be E. They want the electric field. So don't bother doing anything. I told you 2 large conducting plates. It was question 1. You use this formula. All right. So sigma is how much? 6.81 times 10 to the minus 7 over epsilon node 8.85 times 10 to the minus 12. Let me go. So it's gonna be 6.81 times 10 to the minus 7 over 8.85 times 10 to the minus 12. You get this. So to 4 significant figures, it's شوف force قصدي you get 7.69 times 10 to the power 4. Question 9. A cube of side 1.5 contains a positively charged particle. The electric field at each surface has magnitude of this. The volume charge density is this. Okay, whenever you see volume charge density, yani you want rho. Okay, and if you go back here, rho is this formula. Q is equal to rho v. Okay, so Q is equal to rho v. So if you want an expression for rho, it's just gonna be Q divided by v. Hala, don't forget, Q is what? Q, according to Gauss's law, remember we're looking at Q, positively charged particle, whatever. Remember, Q enclosed over epsilon node is equal to EA. Yani Q is gonna be EA epsilon node. EA, right? So it's gonna be rho is equal to EA epsilon node over V. Type, how do we find this? Very easy, let's do it. What's the electric field? 760. What's the area? Surface area of a cube is what? 6s squared, right? A cube has 6 faces. The surface area of it is 6 times each square, so 6s squared. So 6 times 1.5 squared times epsilon node 8.85 times 10 to the minus 12 all over V. What's the volume of a cube? It's s cubed, right? Put this on your calculator, you get this. Alright, let's do it there. Let me pause, I'll do it off camera. So it's 2.7 times 10 to the power negative 8, because to 1 decimal place, you round it. Yellow, easy. Type yellow. Question 10, we're getting there, guys. Alright, so question 10, this is the one I told you where you need to use this. Alright, how do you know? A long copper wire radius this. I told you when you have a wire and they tell you they want the electric field at a distance from the wire, so you have to use that the electric field is lambda over 2 pi r epsilon node. Okay, but here they didn't give me lambda, they gave me sigma. How do I convert from sigma to lambda? I told you lambda is equal to sigma times 2 pi r. So actually let's do that. So lambda is equal to sigma, which is 5 times 10 to the negative 6 times 2 pi times the radius, which is what? Radius of not how far it is, radius of how far the how big the wire is. So times 0.001. Now let's do this on a calculator. 5 times 10 minus 6 times 2 pi times 0.001. You get let's just say 3.142 times 10 to the minus 8. So now let's find E. Lambda is going to be 3.142 times 10 to the minus 8 all over 2 pi. Now the radius here, r, is the distance. Okay, this isn't 0.01 anymore, 0.001 anymore, it's the distance. So it's going to be 0.15, 8.85 times 10 to the negative 12. يلا كلها حطها كبها بالكالكوليتر. 3.142 times 10 to the minus 8, or let's just say answer because it's the answer I got, yeah, over 2 pi times 0.15 times 8.85 times 10 to the minus 12. So you get to 2 decimal places 3.77 times 10 to the power 3. Question 11. Okay, a disc of diameter 6 centimeters is placed in a uniform electric field of this, and they said that the field lines are initially perpendicular to the surface of the disc. What is the electric flux? To calculate electric flux, I told you it's EA cos theta. Now, why do many people get this wrong? Because they take theta as 90 degrees. This is completely wrong. Okay, initially perpendicular. Now, the theta is the angle between, let's say this is the surface, this is the electric field. Okay, it's not the angle between the electric field and the surface, it's the angle between the electric field and the line perpendicular to the surface. The line perpendicular to the surface looks like this, right? It's perpendicular. Okay, what's the angle between E and that line? We call it N. What's the angle between it? It's 0 degrees. So theta is 0 degrees. So when we say that the lines are perpendicular to the disk, we say theta is equal to 0 degrees. Anyway, so EA cos 0. What's E? It's 4 times 10 to the 3 because it's kilo. What's A? It's a disk. What's the area of a disk? It's pi r squared. So pi times 0.03 squared. ليه 0.03؟ أول شيء because you need to make it meters. Okay. تاني شيء because this is the diameter. أنت you need r radius, so you'd have to divide by 2. Okay. 0.03 squared times pi. Alright, and you get 11.3. Now they said it's deviated now by an angle of 30. So what do you have to just multiply by? What's theta now? Theta is now 30. So you have to multiply by cos 30. And you get 9.79. Question 12. A cylinder of radius 3 and length 12.5. So I know always when I see length and radius and whatever, I think I know it's an A. Okay. It has total charge this, so you have Q. They want what? The surface charge density. Okay. It's uniform by the way. They want the surface charge density, so you say you're looking for sigma. Alright. How do you relate sigma, Q, and A? Isn't Q equal to sigma A? Right? So Q 7.5 times 10 to the minus 6 equals sigma, which we're trying to find, times A, which is, it's a cylinder. What's the area of a, what's the surface area of a cylinder? 2 pi r h plus 2 pi r squared. So it's going to be 2 pi 0.03 0.125 because it's 2 pi r h plus 2 pi r squared, so 0.03 squared. Alright, so going to be 2 pi times 0.03 0.125 plus 2 pi 0.03 squared. Alright, so finding sigma is just gonna be this divided by this. That's a lot of math, let's just do it together. 2 pi times 0.03 times 0.125 plus 2 pi radius squared to 0.03 squared. You get like, okay, whatever this is. So 7.5 times 10 to the power of negative 6 divided by this. You get, they want it in micro, so you multiply by 10 to the power of 6. So you get 256.7, which is just 257. Okay. Question 13. They said, select the shape of the Gaussian surface used to find an electric field outside a long straight vertical wire. A long straight vertical wire, akid, it's not going to look like this because this is a horizontal wire. Yani, you guys aren't stupid. Okay. So obviously it won't be this one. It's a wire. Can a wire be plates? These are plates. I mean, obviously no. Well, this one no. So this is a sphere. Is this a wire? No. It has to be a cylinder, yamni. So akid it's gonna be this one. Really, this is grade 1 science question. Okay, question 14. This, I'm gonna give it to you, Cash. Skip it. If you want to watch the solution, watch it. But I doubt it's gonna come. Okay, they gave you the electric field. They want you to find the flux. Since the electric field is a function of x, you need to find the integral. Remember that flux is equal to integral, closed integral, EDA. So it's gonna be integral closed 3 times 10 to the power 4x squared dA. Now, it's a closed integral. When you actually want to open the integral, you have to make it a double integral. Okay? Outside, you're going to have the x integral. Inside, you're going to have the y integral. The x integral will be from where to where? Negative 0.1 to 0.1. The y integral will be from where to where? From 0 to 0.1. Of what? 3 times 10 to the power 4 x squared. And this dA will become what? dx dy. The first thing we do is the inner integral. Okay? The inner integral. You're integrating with respect to what? Since we're doing which parameter? The y parameter. With respect to y, so it's going to look like this after integrated. 3 times 10 to the power 4 x squared. dy will turn into y since you integrated it. Integral of dy is just y. Okay? dx. And what's the parameter of the y? From 0 to 0.1. And now we finished from this integral, so now we're left with the x integral. We're done like this. Now this y, what is y from 0 to 0.1? Isn't it 0.1 minus 0, which is 0.1? Yes. So we're going to change it to this integral, negative 0.1 to 0.1. 3 times 10 to the power of 4x squared times the y, we said it's 0.1 dx. Now this times this gets you this. And don't forget your parameters. Alright, and now integrating this would get you 3 times 10 to the 3 x cubed over 3 from where to where? From negative 0.1 to 0.1. Okay, and now this is going to be very easy. 3 and 3 can cancel. مش cancel إنه خلاص. You'll get this and this you're going to get. So 1000 x cubed from negative 0.1 to 0.1. Also, you don't have to integrate it. The second you reach here, you can just throw it in your calculator, huh? Integral 3 times 10 to the power 4 times x squared times 0.1 from negative 0.1 to 0.1, and you get 2. So the answer is 2. Alright, so that's your answer. Thank you so much for watching, and good luck in your exam.